Good morning, dear students. A warm welcome to all of you for our today's digital revision session. Today, we are going to continue with our revision for the subject Science and Technology, Section A. In our previous session, we have completed the revision for chapter number 4. Today, we are going to revise chapter number 1 and 2, which were there for your first online assessment. So let us begin with the revision for chapter number 1, that is gravitation. The first definition which you have to revise under this chapter is centripetal force. Centri, the word itself tells you that it is related somewhere to the center. So what is centripetal force? A force which acts on an object moving along a circle and is directed towards the center of the circle is called centripetal force. Or in other words, centripetal means center seeking towards the center. Now, this centripetal force can be asked as a fill-up or it can be asked as a definition. Next concept is very important, that is Kepler's laws. Total 3 laws are there. This question was asked in March 2020 board exam. This diagram was given. Children had to identify which laws it were and then state all the 3 laws. So looking at the diagram, you should identify that it belongs to Kepler's laws of motion, and then they had expected you to define all the 3 laws. So see children, directly also questions are not asked in the board exam. They did not give state the Kepler's 3 laws of motion. Means you should be not only thorough with the definitions, not only thorough with the laws, but each and every diagram should also be seen by you before going for your exam, whether it is your online assessment or whether it is your board exam. So Kepler's first law, the orbit of a planet in an ellipse with the sun at one of the foci. The orbit of a planet is an ellipse with the sun at one of the foci. Now these are the laws. So you should learn the laws in the same format as they are given. Kepler's second law, the line joining the planet and the sun sweeps equal areas in equal intervals of time. And the third law is the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Thus, if r is the average distance of the planet from the sun and t is its period of revolution, then t square directly proportional to r cube. See here, cube of the mean distance. That is t square upon r cube is equal to constant, which is k. So these are the 3 laws of motion derived by Kepler. All the 3 laws should be studied properly as they are given in the textbook. Our next concept is from this Kepler's laws. Kepler obtained these laws simply from the study of position of planets obtained by regular observations. He had no explanation as to why the planets obey these laws, but now how using these laws helped Newton in the formulation of his theory of gravitation, and he came ahead with his universal law of gravitation. So according to this law, every object in the universe attracts every other object with a definite force. So it is a very important concept which should be known by you. Every object in the universe attracts every other object with a definite force, and hence it is said, see children, always speak about good things, because this entire universe is based upon the law of attraction. Whatever you speak, the way you behave, you are going to attract the things towards you. If you speak, you behave in a positive way, you always go on speaking good about others, you keep good thoughts, positive thoughts in your mind, then the same will be attracted towards you. Scientifically also it is proved, and hence see, parents keep on telling you कि always speak good things, do not shout in a louder voice, do not speak in a louder voice in your homes. So that is the scientific concept behind it, कि every object in the universe attracts every other object with a definite force. This force is directly proportional to the product of the masses of the two objects and inversely proportional to the square of the distance between them. So the attraction force, it is directly proportional to what? Product of the masses of two objects and inversely proportional to the square of the distance between them. Considering two objects with masses m1 and m2 which are kept at a distance small d from each other, mathematically the gravitational force of attraction between these two bodies from this law can be written as force is directly proportional to product of the masses. So m1 multiplied by m2 and inversely proportional to square of the distance. So d square, or F is equal to remove this sign we have taken capital G, m1 m2 upon d square. What is G? It is the constant of proportionality and it is called as universal gravitational constant. Now ahead you also have a small g, which is acceleration due to gravity. Both of this have to be applied in the numerical examples. So both this concept should be thorough in your mind. Capital G is different and small g is different. So what is capital G? Universal gravitational constant. Ahead we will see what is small g. Next is how Newton arrived at the inverse square law of gravity by the three laws of Kepler. This is very important question for the upcoming board exam. Here you have to consider a planet which is revolving around the sun in a circular orbit in uniform circular motion. Now circular motion means which force will act? Centripetal force which is acting on the planet towards the sun must be F is equal to mv square upon r. What is m here? It is the mass of the planet. V is the speed with which the planet is moving and r is the distance of the planet from the sun. The speed of the planet can be expressed in terms of the period of revolution t as follows. Here you have to apply simple maths. Distance traveled by a planet in one revolution is nothing but perimeter of the object 2 pi r. Application of formula from geometry, where r is the distance of, already we have mentioned over here, it is the distance of planet from the sun. Time taken is the period of revolution, that is capital T. So what is V? V is distance traveled upon time taken. What is the distance traveled? Distance traveled is nothing but the perimeter, that is 2 pi r. So 2 pi r upon time taken is equal to T. That is mv square upon r. See, here we have seen F is equal to mv square upon r. So what is v square? 2 pi r upon t. Just now we have taken speed. So 2 pi r upon t the whole square upon r. So here 2 square is 4 pi square r upon t into t. Now multiplying and dividing by r square, what you will get? F is equal to 4m pi square upon r square, r cube upon t square. How? According to the Kepler's third law, that is t square upon r cube is equal to k. Therefore, F is equal to 4 multiplied by m multiplied by pi square upon r square k. But 4 multiplied by m multiplied by pi square upon k is constant, and thus Newton concluded that the centripetal force, which is the force acting on the planet, is responsible for its circular motion. That force must be inversely proportional to the square of the distance between the planet and the sun. And this derivation is very important. Next is Earth's gravitational acceleration. Just now I had told you that small g and capital G are different. So this Earth's gravitational acceleration is nothing but small g, acceleration produced in any object. In the 9th standard you have studied about the term acceleration. What is acceleration? The rate of change of velocity. So acceleration produced in an object due to the gravitational force of the earth is called as acceleration due to gravity. Now we are going to derive this value of Earth's gravitational acceleration, that is g, on the surface of the earth. For that you will consider an object of mass m situated at a distance r from the center of the earth. What does the law of gravitation tell us? Just now we have studied force is equal to g m upon r square. Here only in the previous Newton's universal gravitational constant we have derived the value of f. G is constant. What is m? M is the mass of the earth. What is small m? Small m, object of mass m situated. What is r? Distance r from the center of the earth. F is equal to mg. You all know force is equal to mass into acceleration. So what is g? G m upon r square. Now here you can see what is m into g. They have given mg is equal to g m upon r square. How? What is f? F is m into g. So in place of f they have taken mg. Mg is equal to g m upon r square. So m and m will get cancelled off. So what remains is small g is equal to g m upon r square. So if the object is situated on the surface of the earth, then small r is equal to capital R, that is on the radius of the earth, because we are deriving the value of g on the surface of the earth. So what is r? R is the radius of the earth, and thus the value of g on the surface of the earth is g is equal to gm upon r square. Now unit of g in SI unit is meter per second square. So unit for acceleration due to gravity is nothing but, last year you have studied the units for acceleration. Same, it is meter per second square. The mass and radius of the earth are fixed. That is 6 into 10 raised to 24 kg is the mass and 6.4 into 10 raised to 6 meter is the radius. Using this and substituting in the above equation, you will substitute the values and you will get g on the surface of the earth as 9.77, which is approximately equal to 9.8, and hence while solving the numerical examples in SI unit we take the value of g as 9.8 meter per second square. Now this acceleration due to gravity depends only on the mass and radius r of the earth, and so the acceleration due to gravity at a given point on the earth is same for all the objects. It does not depend upon the mass of the object. Hence the acceleration due to gravity at a given point on the surface of the earth, it is same for all the objects. And after this we had seen the variations in the value of g, that is along the surface of the earth. There we had seen that the value of g, it depends upon the surface of the earth. You know that the earth is not actually spherical. It bulges at the equator, flattens at the poles, and hence the value of small g, it is highest on the poles, that is 9.832 meter per second square, and decreases slowly with decreasing latitude. So at the equator it is 9.78 meter per second square. So here it can be a fill up or true or false. Then we had seen how it changes with height, and also we had seen how it changes with depth. So variations also we had studied. Next very important topic is the difference between mass and weight of an object. You all know that what is mass and what is weight when it comes to distinguish between them scientifically. Mass is the actual amount of matter present in the object. Mass, always while speaking we say what is your weight, we ask what is your weight, but actually what you speak, that is the amount of matter, that is mass. So mass is amount of matter present in the object, whereas weight of an object is defined as the force. So you can see weight is not the actual amount, it is defined as the force with which the earth attracts the object towards itself. Or in other words, you can say that weight is nothing but force. SI unit of mass is kg. If you want to speak about the CGS unit of mass, it is grams. So SI unit is kg, CGS unit is grams. Weight being a force, the units of force are applicable for weight. So SI unit of force is Newton. So SI unit of weight is also Newton. Mass is a scalar quantity. Weight is a vector quantity. Now mass, its value does not change even when we go to another planet, but weight is force. And what is force? Force is equal to mass into acceleration due to gravity. And acceleration due to gravity, it changes on different planets, and hence the value of mass will not change when we go to another planet, but the value of weight will change from one planet to the other. What is according to Newton's first law? According to Newton's first law, it is the measure of inertia of an object. And for weight, I have already told you, as the value of g is not same everywhere, the weight of an object changes from place to place, although its mass is constant. What is weight? Weight is nothing but the force. What is force? Mass into acceleration due to gravity. So mass remains constant, but weight will change. Why it will change? Because it is a product of m multiplied by g. So as the value of g, here also you see at the poles value of g is different, at the equator value of g is different. So on the earth's surface also weight will differ at the poles and at the equator. So while application of this topic, this concept, they can ask you that why weight is differing on two places on the surface of the earth. There you have to apply this simple concept. So here we complete with the concept mass and weight. Next concept is free fall. A good example we had taken about free fall in Yazoo Park. Whenever an object moves or whenever an object falls under the influence of force of gravity alone. I had taken an example of Yazoo Park. You know that free fall, how you all come down automatically. So that is moving only and only under the influence of force of gravity. Then its motion is said to be in a free fall, which is actually applicable only and only in space, where other forces do not play any role. And last term for this chapter is escape velocity. When an object is thrown in vertically upward direction from the Earth's surface, the minimum initial velocity of the body for which the body is able to overcome the downward pull by the Earth and can escape the Earth forever. We had taken the example of spacecrafts. So they escape the Earth's surface forever, and that velocity is known as escape velocity. We had taken an example that when a ball is thrown upwards, its velocity decreases because of the gravitation of the Earth. Now this velocity becomes zero after reaching a certain height. And after that what happens? The ball, it starts falling down. So its maximum height, it depends on its initial velocity. And then we had seen higher the initial velocity, higher is the height which is reached by the ball. And what is the reason for this? Higher the initial velocity, the ball will oppose the gravity of the earth more, and larger will be the height to which it can reach. But then we had seen that at a point the body is able to overcome the downward pull by the earth. Whenever anything is thrown in the upward direction, you know that after reaching a certain height, it comes back due to the downward pull of the earth. But in some cases, like for spacecraft, all the conditions are in such a way that the spacecraft should escape the earth's surface. So that velocity, that initial velocity is known as escape velocity. So here we have completed the revision of main concepts, main topics for chapter number 1. Now it's your time to keep on reading, understanding the concepts and knowing how to apply them in solving the numericals or any of the answers. So as I have told you, you have to not only prepare yourselves for the upcoming third online assessment, but each and every exam you are going to consider as a climbing step towards your board exam. So keep yourself prepared according to the board paper pattern. We never know what changes the board is going to do at the end moment. We don't know whether we are at what time, in what period we are going to come out of this pandemic. So we have to be prepared in all the ways. Whatever way let the board decide, we are prepared thoroughly with all the concepts. They can take your board exam by taking only MCQs, or they can take by following your proper paper pattern. Our duty is to keep ourselves prepared. See, when you go to a jungle, you want to hunt a small rabbit. You will only take the things which are required for hunting of a rabbit. No. If a tiger comes, what will happen? Whatever things are used for hunting of a rabbit, are they going to be useful there? Surely it will not. So, same here is for our board exam. We don't know how the board is going to conduct the exam, so we cannot prepare according to our wish. We have to prepare very thoroughly all the textual question answers, each and every page reading, what diagrams are there, what activities are there which are excluded by the board. So all that matter you should read and keep yourselves updated. So now we start with the revision for chapter number 2, that is periodic classification of elements. Here in the beginning you have two different laws, that is one is Dobrynin's law of triads and second is Newland's law of octaves. So let us begin with the first law, that is Dobrynin's triads. As I have told you, what do you mean by triad? 3. So why the name was given as triads? Because Dobrynin made group of 3 elements each having similar chemical properties, and then he called them as triad because 3 elements. You know, 1 means mono, 2 di, and 3 means tri, and hence it is known as Dobrynin's triads. He arranged the 3 elements in a triad in an increasing order of atomic mass. Already in the 9th standard, you have studied what is atomic mass, what is atomic number. So he arranged the 3 elements in a triad in an increasing order of atomic mass and showed that the atomic mass of the middle element was approximately equal to the atomic mass of the other 2 elements. And a good example we had taken lithium, sodium, potassium. Lithium's actual atomic mass was 6.9. So by adding the atomic masses of lithium and potassium, dividing by 2 because average, so you got the actual atomic mass of sodium. Next is Newland's law of octaves. For triad, it was for a group of 3 elements. Here why octaves? Let us see. Newland also followed the same track of Dobrynin, that is, he arranged the elements in an increasing order of their atomic masses only. So when elements are arranged in an increasing order of their atomic masses, every 8th element show properties similar to that of the first 8th element, and hence the name is law of octaves. Sodium is the 8th element from lithium and both have similar properties. Also, magnesium shows similarity to beryllium and chlorine shows similarity with fluorine. So this is Newland's law of octaves. So you have to be thorough with both the laws. What limitations were faced by Newland, that also you should know. And next ahead we start with Mendeleev's periodic law, Mendeleev's periodic table. You know that the Russian scientist Dmitry Mendeleev, he developed the periodic table of elements. In which period? During the period 1869 to 1872. And his periodic table is the most important step in the classification of elements. Why? Because he considered the fundamental property of elements, that is again the atomic mass only, as the standard, and he arranged all the 63 elements known at that time. So when Dobrynin's law of triad was discovered or Newland's law of octaves was put forth, some of the elements they did not follow, they did not obey that particular law, hence their law did not succeed up to a particular extent. It was limited. it was limited for a particular group of elements. See, when you are classifying something, it should be followed equally and uniformly by each and every case, which was not possible for Dobrynin and Newland. But for Mendeleev, up to a certain extent, he was a very successful scientist because he arranged all the 63 elements which were known at that time in again an increasing order of their atomic masses. And hence, he organized the first periodic table on the basis of chemical and physical properties of the elements. What he found? He found that the elements with similar physical and chemical properties repeat after a definite interval of time, and on the basis of this finding, he stated his periodic law, which states that properties of elements are periodic function of their atomic masses. He was a very successful scientist. So let us see what are merits and demerits of his periodic table. Merits are, the first merit is atomic masses of some elements were revised so as to give them proper place in the periodic table. See, when I had taught you this chapter, I had told you, suppose take an example of your class. When the classification has to be done in the catalog, certain rules have to be followed. So the rules which are followed are according to your surname. The students are arranged one below the other. Each and every child should get his or own unique roll number. So here also the elements has some of the atomic masses of elements he revised to give them proper place in the periodic table in accordance with their properties. And for example, the previously determined atomic mass of beryllium, which was 14.09, he changed to the correct value 9.4, and then beryllium was given a place before boron, which was surely an achievement for Mendeleev. So that was his first merit. Mendeleev kept vacant places in the periodic table for elements not discovered till then. Means before the elements could be discovered, he had kept the places for that elements, and later on when the elements were discovered, they found their proper places, their properties, everything matched properly. So three of these unknown elements were given the names Ika-boron, Ika-aluminium and Ika-silicon from the known neighbors, and their atomic masses were indicated as 44, 68 and 72. He had predicted. Not only this, but their properties were also predicted by Mendeleev. Later on, when these actual elements were discovered, their names were given as scandium, gallium and germanium respectively. The properties of these elements after their discovery, they matched with those which were predicted by Mendeleev. Means see the amount of knowledge which he has applied over here. And due to this success, all were convinced about the importance of, see, anything you discover before anything comes, predictions which are made by our meteorological department, and then if it rains at that particular time, then surely it is an achievement for the department. So similarly, in the case of Mendeleev, whatever properties he had predicted for that undiscovered elements, later on that properties matched, and hence this method of classification of elements, it was accepted immediately. Why? Because people were convinced about the importance of his periodic table. And lastly, there was no place reserved for noble gases in Mendeleev's original periodic table. But later on, when these noble gases such as helium, neon and argon were discovered, towards the end of the 19th century, Mendeleev, he created the zero group without disturbing the original periodic table, and in that zero group these noble gases were fitted very well, so the original places of other elements were not disturbed. But as you know, every coin has two sides. Whenever there are any merits, surely it will be having some demerits. The first demerit was the whole number atomic mass of elements cobalt and nickel is the same. Therefore, there was some mistake. There was some unsurety in the mind regarding their sequence in Mendeleev's periodic table, because his periodic table also was based on atomic mass. This fault, how it was rectified later in Moseley's modern periodic table, we are going to see. Isotopes were discovered long after Mendeleev put forth the periodic table. Means at the time of Mendeleev, isotopes were not there. The concept of isotopes was not there. As isotopes have the same chemical properties but different atomic masses, a challenge was posed in placing them in Mendeleev's periodic table. Third was, when elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. Therefore, it was not possible to predict how many elements could be discovered between any two heavy elements. And fourth, very important, was about the position of hydrogen. Now, this hydrogen, it shows similarity with halogens also, and also there was a similarity in the molecular formula of compounds of hydrogen with alkali metals. So there was Mendeleev was not sure as to how to place or which position to be given to hydrogen, because it resembles both halogens also and alkali metals also. So where to place this hydrogen was a big problem ahead of Mendeleev. And if any of the element is not getting a proper position, means your discovery is not up to the mark. So it is counted under a demerit. Now, whatever were these demerits of Mendeleev's periodic table, how it was rectified with proper explanation by Henry Moseley in his modern periodic table, we are going to see in our next upcoming session. Till then, all of you are expected whatever we have revised today, page wise you are going to read and you are going to revise all the textual answers and solve the numerical examples. Thank you.